So here we've got two resistors in series, obviously with a power supply. We know the potential difference across the second resistor, but not across the first resistor, and we don't know the potential difference of the power supply. So we know that the potential difference across R2 and the resistance of R2. So we can just use the equation I equals V over R, and V is 3, R is 4, so 3/4, 0.75 amps. Now, if you remember from our the rules for series circuits, we know that the current everywhere in a series circuit is the same, because due to basically conservation of charge. So as the current flows around the circuit here, it's a flow of electrons, it's a flow of electric charge, and we know that basically as it flows around the circuit, there is only one route for it to go along. Electric charge doesn't get used up, the electrons do not get used up in the circuit, so they continue to flow around the circuit and you get the same current everywhere. So that means that so we've now worked out the current through R2. As we've just said, we know the current now everywhere in the circuit. So the current through R1 is just 0.75 amps because it's the same everywhere in the circuit. The current through the battery is 0.75 amps. It's the same everywhere, here, everywhere. Okay, so the next thing to do then is work out the potential difference across R1. So we can do that using V equals IR. Now, because we know the resistance of R1 and we know the current flowing through it, which is 0.75 amps, we can just do 0.75 times by 6, which gives us 4.5 volts. So we know that the voltage across this now is 4.5 volts. And then finally, we want to work out the potential difference or voltage across the battery. And the way to do that now is, if we know the potential difference across this resistor and this resistor, if you remember from the rules for series circuits, the potential difference of the components add up to the potential difference of the power supply or battery. So basically we just do 4.5 plus 3, which gives us 7.5 volts.